Hi everyone. So in this session we are going to see the summary of the previous coordinate system. Then we will see some important points which are necessary to solve the problems, and then we will see the questions. So do not ignore this video thinking that this is just a problem solving video. I have seen a lot of students ignoring problem solving videos. But here you will get to learn a lot of new concepts, and those concepts will be used in vector algebra. So first let's start with the summary. So this is what we studied in Cartesian, cylindrical and spherical coordinate system. What was our differential length? Dx dy dz in ax ay az direction. For cylindrical it was d rho, rho d phi and dz. D rho, rho d phi and dz. Okay, this is how you will remember. And in case of spherical, what is it was? Dr, r d theta, r sin theta d phi. Dr, r d theta, r sin theta d phi. Right? What would be the volume? Simply multiplication of all the small length in all the direction. So dx into dy into dz, rho d phi dz, and here r square sin theta dr d theta d phi. Okay, so you just need to write down the differential length, then you will be able to write down differential volume very easily. And what was your surface area? So for surface area we saw different kind of surfaces first. So this was for x equals to constant surface. So if x equals to constant surface is given, then what will be its normal component? Normal component will be ax cap. And if y equals to c is given, normal component ay cap, and z equals to c is given, normal component az cap. Right? And what will be the surface area then? So if I am taking ax in action, then forgetting about dx, dy and dz will come. If I am taking ay in action, then forgetting about dy, dx and dz will come. And if I am taking az in action, then forgetting about dz, dx and dy will come. Same goes for this one as well. Here what was the surface? Rho equals to constant. Here what was the surface? Phi equals to constant. And here what was the surface? Z equals to constant. In this case, what was the surface? R equals to constant. Here theta was constant, and here phi was constant. Well and good. Right? And just if r is constant, so the parallel component would be ar cap. And what will be the surface area? Forgetting about dr, r d theta, r sin theta d phi, that will come. So that can be written as r square sin theta d theta d phi. Theta equals to constant, so forgetting about a theta, dr r sin theta d phi would come. So that can be written as r sin theta dr d phi. And same goes here. We will solve the problems based on these concepts. And what else we saw? Conversion. So from Cartesian to cylindrical, this was your rho, this was your x, this was your y. So rho cos theta was x, rho sin theta was y. And what was your z? Z was z only. And from here, if you want to calculate rho, so root x square plus y square, what was your phi? Tan inverse y by x, and what was your z? Z was z only. Very simple. What about Cartesian to spherical? So what was your x? This was your r. So r sin theta cos phi. This was your r sin theta on xy plane, and then cos phi. Okay, what was your y? R sin theta sin phi. That was your y. And what was your z? Z was r cos theta. Very simple. And this is the value of r, phi and theta. From here you can find the phi as well. How will you find? Tan inverse y by x only, because this phi and this phi are same only. This phi and this phi same only. R was simply root x square plus y square plus z square. And what was your theta? Theta was tan inverse root x square plus y square by z. How would you remember theta? So theta was tan inverse rho by z. If you remember the diagram, this was your r. This would have been your rho. If you see from here, like this I am showing in 2D only. So rho would be just simply this was your projection, so simply I am copying it here, and this was your theta. So what would your tan theta? Tan theta would have been rho by z. And what is your rho? Root x square plus y square. Right? So this is how you can remember it. And then the other conversion, which is very simple. What was your rho? Rho was r sin theta. What was your z? R cos theta, and phi was the same only. And from here you can calculate r, theta and phi as well. Conversion matrix, do you remember how I told you to write? Okay. So that I am not writing again, because that was just a simple trick. You will write down these values, and then you will see whether they are depending on r or not. Here you will write down these values, and you will see whether they are depending on rho or not. Right? And here also there you will write down these values, and you will see whether they are depending on r or not. And then you differentiate, and then you write down the conversion matrix. And dot product also you can write down in the same manner, or you can solve it intuitively as well by geometry. Right? So this was the summary of everything that we have studied till now. In 5 minutes we have done the complete summary. Now we will see a few points which will be useful for solving the problems. Also it will be useful in vector calculus. So that is our next chapter, that is vector calculus. So it will be useful there. So this will be useful for solving the problems. So this we have already seen, right? Scalar component of vector A on vector B. There I wrote this thing. So this thing also I can write, but if I have mentioned scalar component, that means I am talking about scalar only. So what was the scalar component of A on vector B? That was A cos theta, right? You take the projection and that would become A cos theta. And what it can be written as? It can be written as vector A dot B cap. Did I tell you this? Yes. What is the magnitude of vector A? That is A only. What is the magnitude of B cap? That is 1. And what is the angle between them? Cos theta. So what it can be written as? A cos theta, right? So this is the other way of representing it. Scalar component, you mark this thing, scalar component of A on B. So this quantity is scalar. This is scalar. Now the same thing can be asked in this manner, scalar component of A parallel to B. I am not asking on B, parallel to B. So this is your B vector. So parallel line will be this, na? This is your B vector. This will be a parallel line, and I need to find the component of vector A on this line. What that would be? Between A vector and B vector, if the angle was theta, then here also the angle will be theta only. Let's just say this is your line. This is your vector A, and I am saying this angle is theta. This angle is theta. Then what would be the angle between vector A and vector B? So what you can do? You can take this vector B simply upward. If I take this vector B upward, what will happen? The angle between vector A and vector B will be theta only. Are you getting this point? Angle between vector A and the parallel line to vector B. Angle between vector A and the parallel line to the vector B is theta. So what will be the angle between vector A and vector B? Theta only. I will again repeat the line. Angle between vector A and the parallel line to vector B is theta. So what will be the angle between vector A and vector B? That will be also theta only, right? So here what will be the component? Component will be A cos theta. A cos theta. This component will be A cos theta only, right? And how I can write this? This is how I can write this. Why I can write this? Because I know between A vector and B vector the angle is theta only. If I solve this, what I am going to get? Magnitude of A into magnitude of B into cos theta. So I am getting cos theta only. This is what I am getting. So scalar component of vector A on vector B or scalar component of vector A parallel to vector B, both are same thing. Are you getting this point? Okay. Because if you are taking something in parallel, that means the angle would remain same only, and the component would come A cos theta only, right? So A vector dot B cap, here A vector dot B cap, both are same thing. So this is what I wanted to show. And what about vector component? So this I did not teach. Here what they are asking, vector component. So what we need to do, first thing is that we simply need to calculate this thing only, that is A cos theta. A cos theta. So component is A cos theta, but that is scalar component. Now what they are asking, vector component of A on B vector. So this component on B vector. So what is the direction of this component? What is the direction of A cos theta on B vector? So that will be B cap. Say yes or no, or I should show it by small, but forget about it. Let's show it by capital letter only. Like basically cap should be shown by small letter, but here I am showing by capital letter only. What I mean to say, this component is vector component. This was your scalar component, A cos theta, but this is your vector component. If this is your vector component, then I need to show the direction as well. This is the magnitude. This is the magnitude. Magnitude is A cos theta. What is the direction of A cos theta? Direction of A cos theta is B cap, right? So A cos theta, this is the magnitude, and this is the direction. Direction I am not gonna write A cap here. I am gonna write B cap because I am finding component of vector A on vector B, on vector B. So this is the direction I am gonna write. So how I can replace A cos theta? That is vector A dot B cap, and then this is your B cap only. So this is your vector component of vector A on vector B. So this is the same thing only, just you need to show the direction as well. And same goes for this one, because this is parallel, and parallel, this line and this line are parallel. So what is the angle between vector A and vector B? That is theta only. And what is the direction of this line? What is the direction of this parallel line? Similar to B vector only. Because if I am saying that this has a direction x cap, then what will be the direction of this line? X cap only. What will be the direction of this line? X cap only. What will be the direction of this line? The magnitude can change, but direction is same. All are pointing towards this line, this line, this line. So all have the same direction. So both things are same only. Vector component of vector A parallel to vector B. So both are same thing. So here also what will come? This is your A cos theta, and then you need to show the direction. So this will be the direction. Okay, well and good. Now let's see something. Angle between vector and a plane. What is the angle between vector and a plane? So this is your plane. This is your plane that is given, and this is some vector. This is some vector. What is the angle between both of them? This is the angle between both of them, right? You need to find this angle theta, or what could be the possible angle? This could also be a possible angle, no? 180 minus theta. Say yes or no? Usually we will take acute angle. Okay, usually we will take acute angle, but there is no hard and fast rule. If someone is asking me what is the angle between a vector and a plane, this is a vector. Look, this is a plane and this is a vector. So this angle it will make, that is theta. One more angle it will make, no, 180 minus theta. So that also I can consider, but usually if it is coming in MCQ, then you will consider this angle, which is acute. So how would you find this? How would you find this? So what I am gonna do, I will find the perpendicular unit vector from the plane. If my plane is rho equals to c, what will be the perpendicular unit vector? A rho cap. If my plane is z equals to c, what will be the perpendicular unit vector? A z cap. If my plane is theta phi equals to c, what will be the perpendicular unit vector? A phi cap. So I can find this vector, right? Then I will find the angle between this vector and this vector. That angle I will call alpha. Then what will be my theta? Theta will be 90 minus alpha. So whenever they are asking me a question that what will be the angle between a vector and a plane, so what I am gonna do, I am gonna find first the perpendicular unit vector I will have, and then one vector I will have, the given vector I will have. So I will find the angle between both of them, and once I have found the angle between both of them, I could know that my actual angle will be 90 minus this angle, because alpha plus theta I know that is 90. So my theta will be equals to 90 minus alpha. So first I will find the angle between perpendicular vector and the given vector, and then I will subtract it from 90. And let's just say if this answer is coming, let's just say you get the value of alpha in negative. You get the value of alpha in negative. So this answer can be coming greater than 90 degree as well. Let's just say this answer came 110 degree. So what could be the other possible answer? 180 minus 110, 70 degree. You found your angle to be 110 degree. That means you are getting this angle. The other angle would be 70 degree, right? We will solve the problems, it will be more clear. No need to worry about that. So very simple concept it was. You must have studied it in your elementary classes as well. The angle between vector and a plane. Unit vector perpendicular to both of the vectors A and B, or you can say unit vector perpendicular to the plane containing A and B. Think about it, what will be the vector? I need to find a unit vector which is perpendicular to both of the vectors. It should be perpendicular to A as well, it should be perpendicular to B as well. Let's just say this is my vector A, and let's just say this is my vector B. I need to find a unit vector which is perpendicular to both of the vectors. Or I can say in this manner that it is perpendicular to the plane containing vector A and vector B. Let me give you an example. This is your vector A and this is your vector B. Okay, let's just say both are like this. So from both of the vectors I can make a plane. From both of the vectors I can make a plane which is passing through both of these vectors. Now I need to find a vector which is perpendicular to both of these vectors. What that would be? This basically that would be this A vector, B vector, and this will be the perpendicular vector. How you can get it? Which operation will you perform? I need to get this vector. Think about it. This would be your magnitude of A cross B, sorry, A cross B divided by magnitude of A cross B. Because what is the direction of A cross B? Direction of A cross B is what? Perpendicular to the plane containing vector A and B. Both of the vectors A to B and perpendicular. So if you need to find a perpendicular vector which is perpendicular to both of the vectors, vector A and vector B, then you simply need to take the cross product. Remember this thing always. By concept also you can think vector A, vector B, perpendicular to both. That means that will be your n vector, n cap. So that will come, how that will come? You take the cross product and then you take the magnitude, because what is the magnitude of A cross B? That is AB sin theta. And what is your A cross B? That is AB sin theta n cap. So if you divide both of them, what you are going to get? N cap. Okay. So this will be used in problem solving. Now this will be used in vector calculus as well. This thing will be highly used in vector calculus. If you do not understand these 2 points or these 2 terms, then you will not be able to understand vector calculus. So it will be used in vector calculus as well. So now understand it very carefully. What do you mean by scalar field? So what do you mean by field first? Field means function. So there can be 2 kind of fields, scalar field and vector field. So what do you mean by scalar field? So let's just say the variation of a temperature in the room is given by x square plus yz. With respect to different value of x and y and z, your temperature will change. What do I mean to say is that your temperature at coordinate 1, 1, 1, what that would be? 1 square plus 1 into 1, that would be 2 degrees Celsius. Your temperature at x coordinate 1, y coordinate 2 and z coordinate 1, what that would be? 1 square plus 2 into 1, that would be 3 degrees Celsius. So in this particular room, at 0, 0, what will be the temperature? 0 degrees Celsius. Let's just say this point is some 1, not 1. Let's just say this point is 3, 3, 3. X coordinate is 3, y coordinate is 3 and z coordinate is also 3. This I am calling as x coordinate, y coordinate and z coordinate. So all are 3. Then what will be the temperature? 3 square plus 3 into 3. What that would be? 9 plus 9, 18. So this will be 18 degrees Celsius. So here temperature will be 18 degrees Celsius. So at different points in the room, your temperature will be varying. So this is like a scalar field. This is known as scalar field. At this point, temperature will be different. At this point, temperature will be different. If you go from here to here, your temperature will be different. If you go from here to here, temperature will be different. Here temperature can be high, here temperature can be low. Here temperature can be high, here temperature can be low. It is depending on the value of x, y, z. So your field is a function of coordinates. Field is a function of coordinate. Here I will not write. Your field is a function of coordinate, but that is not vector, that is scalar. Your temperature is 2 degrees Celsius, that is a scalar quantity. 3 degrees Celsius, scalar quantity. 4 degrees Celsius, 10 degrees Celsius, 15 degrees Celsius, 18 degrees Celsius, that is a scalar quantity. So in a room, your temperature can be shown something like this. What do I mean to say that? I can say that blue color means low temperature. Okay, green color means high temperature, and this roughly it could be called orange color. So orange color means very high temperature. Okay, so if I see any other color, this color means very low temperature. So this I am denoting like that. This is not certain that here at this point very high temperature or here very low temperature. No, I am not plotting this field here. This is not plotted here. This is a random scalar field that has been plotted. A random scalar field that has been plotted here. I am plotting a random scalar field. So at some point, some different value you are getting, at some point different value you are getting. So at different points in the room you are getting different value. This is known as scalar field. So your field is distributed in the room with respect to x, y, z coordinate. So your field is depending on x, y, z coordinate, and that is a scalar quantity. You put the value of x, y, z 1, 1, 1, 1 to 1 and you are gonna get a scalar quantity. Okay, so this is what do we mean by scalar field. What do you think what will be your vector field? It will be the same as scalar field only, just vector components will come there. So let's just say this is how I am defining my vector field. This is some of the vector field. So what will be my vector field at point 1, 2, 1? What that would be? So 1 plus 2, 3ax plus z minus x, What would be z minus x? 0 minus 0, that would be 0 ay. So let's not make it 0, let's take it 2. Okay, so 0, 2 minus, so you could have taken 0 as well, just I wanted to show all the coordinates, that's why I am taking not 0. So 2 minus 1 ay plus y minus xy, 2 minus 2, okay, y minus xy, now this is becoming 0. So let's change this one as well, let's make it 3. So 3 plus 2, this would be 5, and this would be 2 minus 3, that would be minus ay cap. And what about this y minus xy? So it would be 2 minus 6, so that would be minus 4 az. 2 minus 6 minus 4 az. So add point 322, add this point 322, wherever it would be 322, you will be getting a vector field. At point 322, you can get a vector field like this. At different point, you will get different vector field. Let's just say I take a different point, that is 1, 0, 0. Let's just say I take this point. So what will be my vector field? Ax cap plus 0 minus 1, that would be minus ay cap, and this is 0 minus 0. So ax cap minus ay cap. So at 1, 0, 0, you are getting your different vector field. Let's just say your vector field are represented by x I cap only, or x ay cap. This is how your vector field is represented. Let's take this example. Vector f is equals to x ay cap. What do I mean by that? At 0, 0, 0, what will be your vector field? 0, 0, 0. Put x equals to 0 here, 0 only. So do not plot it. At y equals to, or let's make it this as x, this as x, this as y, this as z. X cross y is equals to z. So this is also correct. So at 0, 0, your vector field is 0. What about at 1, 0, 0? What will be your vector field? At 1, 0, 0, your vector field is ay cap. Your vector field is ay cap. So magnitude 1 and direction ay. So this is how you will show your ay cap. Magnitude 1 and direction ay. What will be your vector field at 2, 0, 0? 2, 0, 0. At 2, 0, 0. What that would be? X value 2. 2 ay cap. So that would be 2 ay cap. Magnitude 2 and direction in y direction. At 1.5, this point would be 1.5, 0, 0. What that would be? 1.5 ay cap. So magnitude 1.5 and direction ay cap. After that, so this is how the vector field will go. This is how the vector field will go. Right? What do you think? What will be the vector field at this point? Let's just say this point is 1, 1, 0. X is 1, y is 1, z is 0. So what will be the vector field there? Vector field at 1, 1, 0. What that would be? X equals to 1 you need to put. Y is not even there. X equals to 1 you need to put. So what you are going to get? Ay cap only. So here also vector field is ay cap. So it's not that here you will not calculate the vector field. Here also you will calculate the vector field. So at different points your vector field will be different. You will get some vector field line, like in this manner you can get, in this manner you can get, at this point you can get, in this manner, in this manner. So there are infinite points, there will be infinite vector lines. Right? So it's not possible to plot all the vector lines. So this vector line, this vector, no, I should not say vector line, this vector field is plotted like this. This I have plotted from some simulating software so that I can show you as well. Yeah, so this is some website, teaching.smp, some you can go there. This is some website. So here I can see this, these are the function I have plotted. This is the function x plus y ay cap plus z minus x ay cap plus y minus xy az cap. Okay, so this is how it looks. So I can rotate it something like this. So this is how the vector lines are looking like. This is your y axis, the green one is your y axis, the red one is your z axis, this is your y axis, this red one is your x axis, and this blue one is your z axis. So this is how the vector lines looks like at different point. They haven't shown all the points, at some discrete points they have shown. Okay, now I can change the values. Let's just say if I change this field, so I am changing this field to, let's just say I change this field to x plus should be small, x plus z plus y. Okay, then this field will be changed. Now this field has changed. Look. So with respect to different coordinates, different field will be there. You can go to this website and you can see that 3D simulation of the field. Okay. So at different point you will have different vectors. That is the thing. At different coordinates you will have different vectors. So this is how you can show your vector field. Okay. So both are the same thing only, scalar field and vector field. The thing is here at different coordinate you will get different vector fields, and here you are at different coordinate you will get different scalar values. Okay, so these terms will be used in vector calculus. Also in the questions as well you will see these kind of things being repeated. Then I will ask you whether it is a vector field or it is a scalar field. So I hope you have understood the meaning of vector field and scalar field. Very straightforward thing, right? Now these two terms will be highly used in complete EMFT, that is uniform versus constant. What do you mean by uniform field and what do you mean by constant field? We will talk about electric field and magnetic field, but here I am talking about a general field. So a general uniform field, what do you mean by uniform? Uniform means it should not be a function of xyz coordinate, or I can say space. In space means it could be xyz, it could be rho theta phi, sorry, it could be rho phi z, or it could be r theta phi. So it should not be a function of space. So tell me whether it is a uniform field or not. This is a vector field, this is a vector field, f is a vector field. Whether it is uniform or not, what did I say? It should not be a function of space, it is a function of time. So yes, it is uniform, it is uniform. The only condition is it should not be a function of space. What about this? This is neither function of time, neither it is a function of space. So certainly it is uniform. And what about this? This is not uniform. Why this is not uniform? Because at different point of space, at different coordinates, you will get the value of field differently. So this is not uniform. Not uniform. Okay. What about these? Constant. What do you mean by constant? Constant means it should not be a function of time. It should not be a function of time. So this is the first one. Certainly it is constant. Second, it is a function of time, not constant. And what about third? This is also not constant, because one is this j cap is a function of time here. In the y direction, whatever the magnitude you are having, that is a function of time. So this is also not constant. Okay. Now let's talk about this. Is this constant? No, because it is a function of time, not constant. Is this constant? Yes, it is constant. So it is uniform and constant as well. What about this? Is it uniform? No. Is it constant? No, because this is a function of time here. So not constant. What about this? Is this uniform? Yes, because it is not a function of space. Is this uniform? Yes, this is uniform because it is not a function of space. This field can change with respect to time, but it will not change with respect to different coordinates. At 1, 1, 1 as well, this will be the vector field. At 2, 1, 1 as well, this will be the vector field, right? And what about this? This is neither constant nor uniform. Okay. So these terms will be highly used, and a lot of students don't even know the meaning of this. They think that constant and uniform are both same thing, but both are not same thing, both are different. Uniform means not a function of time. Okay. So how will you remember? Constant. Constant. So T is coming now. So should not be a function of time. T stands for time, right? You should not be getting confused in the examination. Uniform means not a function of time or space. So you should not be getting confused. You will realize that there are two words, uniform and constant. Constant T. So that should not be a function of time. So that means uniform means that should not be a function of space. Well and good, very straightforward. Okay. So yeah, that's it about the summary and some new points that I wanted to deliver. These will be highly used in EM wave as well. These will be used in your vector calculus as well, and these will be used in solving the problems as well. So let's quickly revise whatever that we have studied. So first we saw the summary. Okay. Then we saw scalar component, both same thing we have already studied. A vector dot b cap. If they are asking parallel, then also it is same. If they are asking in a particular direction, if they are asking vector component, then you need to show the direction as well. Then we saw about the angle. So this is a vector, this is a space. So if I can calculate the perpendicular vector of the space, then I can calculate the angle between perpendicular vector and a vector. How will I calculate this angle? I know what is the angle between two vectors. I know what is the angle between two vectors. If this vector is my n cap and this vector is my a cap, so can I tell what is the angle between these two vectors? Yes. The angle will be cos theta equals to n cap dot a cap. How am I writing this? A cap dot n vector, what that would be? Magnitude of A, magnitude of n, cos theta. So cos theta will be what? Here it is alpha, so let's not get confused. Here the angle is alpha. Okay, so this is the angle alpha. So what will be your cos alpha? Divided by magnitude of A. So what this value is? A cap. And what is this value? N cap. So what we are getting? Cos alpha is equals to n cap dot a cap. So this is how I am going to find my cos alpha. If I know the cos alpha, that means from here I can get the alpha as well. And if I know the alpha, so don't forget to do this thing. Many times student will just find this and then they will say that this is the angle between vector and the normal component. Sorry, yeah, this is the angle between vector and the normal component, but this is not the angle between your plane and the vector. Angle between the plane and the vector is 90 minus alpha. Okay, so don't forget to do this thing. So once you find alpha, after that you need to do theta equals to 90 minus alpha. Okay, very easy. Then if you need to find a unit vector which is perpendicular to both of the vectors, that is vector A and vector B, then you just need to do the cross product. Okay, and take the magnitude of that. Scalar field, vector field at different point in the space, it will be a function of particular coordinate system. Okay, so here it is, the temperature is a function of x, y and z. Here also it will be a function of x, y, z, or it could be a function of time as well, but the thing is they will be vectors. So at different points you will be getting different vectors. So here we plotted this thing, vector f is equals to x a y cap. So what we are getting? X a y cap, what we are getting? So this vector we were getting, this kind of field we were getting. So at different point different fields will be there. Okay, and then we saw the meaning of uniform versus constant. Now we are going to see the assignments, and from where these questions are coming? These questions are coming from Sadiku textbook. So I am not taking credit of any of the questions. So these questions I am directly copying from Sadiku textbook. So not taking any credit that these have been framed by my own. No, these questions haven't been framed by my own. I will frame the questions, but that will come into test series, not here. Okay, so yeah, so these are directly questions coming from Sadiku. So we will solve the problem, but let's take a simple break, a short break. I will drink some water and then I will come back. You can also take a break of 5 to 10 minutes, then you can start solving the problem. So this is the first one. I can show you the problems first. So first one, you can pause and now try solving. Then this is the second one, you can pause and try solving. Third one, pause and try solving. Fourth, if you are not able to solve that then also it is fine, because these cannot be directly solved. First I will tell you the problem solving technique, then you will be able to solve. So if you are not able to solve these problems, then also it is fine, do not worry. Okay, fourth, fifth, sixth, then differential length, area and volume based problem will come. These are also coming from Sadiku only. Sixth and then seventh. So these 7 problems we are going to solve. You can pause it and then try solving it. I will drink some water and then I will start with the first problem. Okay, so yeah, let me pause the video. Yeah, so let's start the first one. So vector A is given, you need to find the tangential and normal component of vector A along the plane z equals to 3. So just let's make the z equals to 3 plane. this will be my z equals to 3 plane. This is x, y and z. So z equals to 3 plane I need to make. So this we have already seen how it is z equals to 3. With respect to different xy value, z will be always constant, that is z equals to 3. So this will be your z equals to 3 plane, right? Tell me what will be the normal component. Normal could be this in this direction as well. Normal component could be in this direction as well, and it could be in this direction as well, right? And what will be the tangential component? These will be the tangential component. Tangential mean on the plane itself. Tangential component. On this point, what will be a tangent? This tangent will be there. On this point, what will be the tangent? This will be the tangent. Tangential component means the components on the plane itself. So these will be my tangential component. But what do we need to find? We need to find these components from vector A. Like there is some vector 3, 4, 6, 3 ax cap, 4 ay cap and 6 az cap. So which of the component of this vector will be parallel to this plane? This plane is my z equals to 3. So which of the components of this particular vector will be parallel to this space and perpendicular to this space? Again I am repeating, which of the component of vector A are perpendicular to this plane and parallel to this plane? So this is what they are asking. So this is your vector A, 3 ax cap plus 4 ay cap plus 6 az cap. So perpendicular component could be plus az cap and minus az cap, but here only plus az cap is coming. So this is the perpendicular component, which is 6 az cap. And what could be the parallel component? Parallel component will be 3 ax cap plus 4 ay cap. Because this 3 ax cap, 4 ay cap would be somewhere here and 6 az cap would be somewhat like this. So this will be your vector. What do I mean to say is that your vector will be something like this, right? So parallel component will be this one in x direction and in y direction, and perpendicular component will be somewhat that is in z direction. So this vector can be broken into three parts, 3 ax cap, 4 ay cap and 6 az cap. So 6 az cap is parallel and 3 ay cap plus 4 ay, 3 ay cap plus 4 ay, that is, sorry, az cap is perpendicular and 3 ax cap plus 4 ay is parallel, right? So there are two components, parallel and perpendicular. You cannot say that, sir, your parallel component is only 3 ax cap. No, it is 4 ay as well. So I will write down both together. So your tangential component is 3 ax cap plus 4 ay and perpendicular is 6 az cap. Very straightforward problem, very easy. Let's see this question. Formula based, okay, completely formula based. So this is the only problem which we are going to solve formula based. After that we will solve the problems without applying any formula, just by simple geometry. You can solve the problems by formula as well. So here I am going to show how to apply the formula. From the next problem onwards we will solve the problems with the simple geometry, okay. So express P in cylindrical and spherical coordinate system. So this is your point P, -2, 6, 3. So here x value is -2, y value is 6 and z value is 3. So what will be the, now I need to express in cylindrical, spherical and cylindrical and spherical only. So cylindrical. So in cylindrical what I am gonna get? What will be my rho? Rho will be root x square plus y square, right? So that will be -2 square 4 plus 36 root 40. And what will be my rho phi? Phi will be tan inverse y by x. Tan inverse y by x. But wait a second. Here x is negative. So let's make the quadrant. X is negative, y is positive. So here that point will be. So what I need to do? I need to find this angle. This angle I will find. And what I am going to do? 180 minus this angle. What will be this angle? 6 by 2. So what will be my answer? My answer will be 180 minus tan inverse 6 by 2. This we have already seen in the basics in the first lecture itself, how to find the angle. So minus 2 and 6. So this angle will be 6 by 2. So whatever the angle theta I am getting, and the angle from x axis we always measure. So that would be 180 minus tan inverse 6 by 2. So 180 minus tan inverse 3. So I have the answer here. That would be 108.43 degree. Okay. And z coordinate is the same as 3 only. Let's write down the spherical coordinates. So from Cartesian also I can write, and from cylindrical also I can write. So from anywhere you can write down. So first I am writing only from Cartesian only I am gonna write. So that would be x square plus y square plus z square. This will be your r. So 4 plus 36 plus 9. 4 plus 36 and z value is 3. So answer will be 7. And what about theta? What will be your theta? Theta will be tan inverse rho by z. So I don't remember that xy formula, I remember only this formula, tan inverse rho by z. Okay. So what is your rho? Rho is 40. And what is z? Root 40, sorry, root 40 by 3. So what will be the answer? Tan inverse root 40 by 3, 64.62 degree. Okay. And what about phi? Phi is the same coordinate. Phi is the same coordinate, which is 108.42 or 42 or 43, 43, 108.43. So we have denoted the elements. Minus 2, 6, 3. Minus 2, 6, 3. In cylindrical it was root 40 value they have given, yes, 6.32. Root 40 is 6.32. These are direct question from Sadiku only. So just calculation based, I just wanted to show you the calculation, because you should not have a doubt that sir we have understood the formula, but how to apply it. So this is how you can apply it. Okay. So r comma theta comma phi. Well and good. Okay. Yeah. So now next question, that is interesting. So first I will solve it formula based, then I will tell the exact meaning of this particular problem. So here you wouldn't be understanding what is the meaning of point P. You need to find vector A. This vector A you need to find in Cartesian, cylindrical and spherical. So first we will solve just by the formula, and then I will tell you what is the meaning of this point P. What do they actually mean here? So let's find out the value of point P in Cartesian first. So this is the second problem we are solving. Sorry, not point P, sorry. Let's find the vector value of vector A. What is a vector A? It is a non-uniform and constant vector field. Say yes or no? Non-uniform and constant vector field. They did not ask it. Neither they are going to ask it in the examination. But for a general knowledge, you should know. What do we call it? Non-uniform, because it is a function of x, y, z, and constant vector field. So you just need to find vector A at point P. Point P is minus 2, 6, 3. So you just put the values. So I will just see the answer. So that is coming out to be, no, they are asking us to calculate first. So okay, 6ax plus ay. So you can put there 6ax plus ay, or it was simple plus ay. Okay, wait a second, this was actually ay. Really sorry for the error. Now your answer will change. Really sorry guys, you must have done the hard work, and here I need to change this variable. Okay, so really sorry for that. Please don't dislike the video. Please don't dislike it. Okay, so just one error I did here. It would be ay. Really sorry for that mistake. So please don't dislike the video in anger. Look, I could have solved it with AZ, but that will take a lot of time. No, here I can directly write down the answer from the textbook itself. But if I make it AZ, then whole answer will change. So really sorry for this error. Okay, please don't dislike the video now, because you are going to learn a lot of new interesting thing in this particular video. So please don't dislike it. In the question itself, you are going to learn a lot of new things. So I'm not afraid, okay? I'm not afraid. You can dislike the video. But just I am telling, I am really sorry for the error. And x plus z, so that would be ay cap. Okay, so this is in the Cartesian coordinate system. Cartesian coordinate system. Now I need to find in cylindrical. So how will I find in cylindrical? A rho, a phi, a z. In cylindrical, how it will be denoted? In cylindrical, it will be denoted as a rho cap plus a phi cap plus az cap. This is how it will be denoted. Then ax, ay, az. Right? What is the formula now? The formula. So x equals to rho cos phi, y equals to rho sin phi, and z equals to z. But I am writing down the opposite. From rho to x I am going. So I will write down horizontally. What is the differentiation of cos? Minus sin phi, cos phi, and then 0. Here 0, 0, this will be 1. How will I get this value of phi? Ax, ay, az I know. What is that? 6, 1 and 0. How will I get the value of phi? From here, 108.43 degree. Okay. So here your phi is 108.43 degree. So this phi value I will put here. So let's see. A rho, a phi, az. So cos 108.43 degree sin 108.43 degree and then 0. What is the value? 6, 1, 0. And then simply the differentiation. So here minus sign will come. Here positive sign will come. Okay. So if you solve it, what you are gonna get? A rho equals to. So directly I am writing down the function. You can see az is coming out to be 0 only. So what I am gonna get? Vector a, that would be equals to minus 0.95 a rho cap and minus 6.008 a phi cap. Do not worry about all these things. I will tell the actual meaning of the complete problem. You might be wondering what is the meaning of this point P. What do you mean by evaluate a vector field A at point P? So I will tell the meaning. Do not worry about that. Let's see the first one. Sorry, let's see the third one. What is the third? Third I need to implement in this. Okay, this was the second question. So this is done in Cartesian. Now I'm gonna go to Cartesian. Now I'm gonna go to spherical. For spherical as well, I can apply the formula r comma theta comma phi. Which one I should apply? I can apply any one. I can go from Cartesian. This is not Cartesian. Sorry. I can go from cylindrical to spherical as well. I can go from Cartesian to spherical as well. Okay. I can go from here to here as well. I can go from here to here as well. How will I go? How should I go? Let's go from Cartesian only. Okay. So what is the formula? R sin theta cos phi. Sin theta cos phi. Y equals to R cos theta. Sorry, R sin theta only, R sin theta sin phi, and Z is R cos theta. So I am going opposite, so I will write horizontally. Sin theta cos phi, sin theta sin phi, and then cos theta. And here Ax, Ay and Az. So what is my Ax, Ay and Az? that is 6, 1 and 0. 6, 1 and 0. Then I need to differentiate. First you need to differentiate with respect to theta and cos phi as it is. Theta phi as it is, and then minus sin theta. Now you will differentiate with respect to phi. What about this? This will be cos phi and this will be 0. Okay, then you put theta equals to what? Theta equals to, you are gonna put 64.62 degree, 64.62 degree, and phi equals to what? 108.43 degree. So you put these values, you are gonna get final vector A. You are gonna get the value of AR, A theta, A phi. So what you are gonna get? So you are gonna get minus 0.8571 AR cap, minus 0.4 A theta cap, minus 6.008 R comma theta comma phi cap. So you must have understood how to apply all the formulas, right? So this answer is coming into spherical. So just for applying the formula, we understood this question. Okay. So these are the 4 answers of this particular question. It will never be asked in your GATE examination. Can be asked in ECE, but never in your GATE examination. But here we understood to apply the formula. Let's pause for a minute. I got some work to do. Then I will come back and explain the meaning of this question. Yeah, so now let's understand the meaning of that point P. Okay. So before understanding the meaning of that point P, you just let me know few things. If let's just say this is your x, this is your y, this is your z, and this is your some point P, that is rho comma theta, rho comma phi comma z. In the air it is. It's not on plane, it is in the air. So how will you find the direction of a rho, a phi and az? What you are gonna do? First I will take the projection of the point, then I will join it from the origin. Now what will be my direction of arrow? This will be the direction of arrow, right? This will be the direction of arrow. Then I will see in which direction my phi is increasing. In this direction my phi is increasing. So this will be my direction of a phi. And what will be my direction of az? This will be the direction of az. Same things I can copy here as well. That from here, if I want to show, this is my direction of arrow, this is my a phi, and this is my az. Well and good. Arrow, a phi, and az. Now let's just say this point is P. Now some point P dash is somewhere here. That has the same coordinate. It couldn't be same coordinate, but I am saying some different coordinate is there. Phi 1, rho 1 and z1. These are the coordinates it is having. So let me make it more clear to you. So this point is somewhere here. This was your P1, this is your P2. So it is having the coordinate phi dash, rho dash and z dash. Now how will I find the direction of rho phi z with respect to this particular coordinate? With respect to this particular coordinate, the direction of rho phi z will change. Say yes or no. I will take the projection on xy plane. I will join it. Now tell me where your rho is directing. Let's change the color of the pen. Where your rho is directing? Here. Where is your phi directing? So phi is increasing like this. So direction of rho has changed. Are you getting this point? With respect to different coordinate, now direction of rho has changed. Now this will be your a phi, and az is the same only. Z is the same only. So now a rho, a phi, a rho 1 I will call, a phi 1 I will call, and a z is the same only. A z1 I can call. So now rho phi and rho phi direction are different. So this is what this point is saying. What this point is saying, that at point P, at this particular point, you plot this point in your coordinate system. You plot this point in your xyz coordinate system. That is 6.23, 108.43 degree and 3. 6, 108.43 4, 3 and 3. You see this point, and then with respect to this particular point, you define your rho, phi and z. You define your rho, phi and z, and then you let me know the direction of a rho, a phi and az. Now with respect to these directions, this is your a rho, this is your a phi and this is your az. With respect to these direction, you let me know how your vector a will look like, how this vector a will look like. So this is what this point is saying. This is the meaning of this point. So this is like a reference point, that with respect to this point, how will your a rho, a phi and az will look like. This is your a rho, this is your a phi and this is your az. So this is your coordinate system. With respect to this coordinate system, how will your a vector look like. So this is the meaning of this point. Actually, for solving the problem, you do not need to think what is the meaning of this point, but in the next problems I will solve all the problems intuitively, like just by showing the geometry. So there I will tell you what is your a phi in terms of x, y, z, what is your a rho in terms of x, y, z, without even applying any formula. Okay, so you should know what is your point P. Point P is a reference point, that with respect to this point, what is your a rho, a phi and az. If you get the direction of a rho, a phi and az, then let me know how will the vector a look like. Are you getting this point? Let's solve the next question now. So two uniform vectors are given. First question E cross F, directly formula based, you don't need to use your mind. In the second question, what they are saying, you need to find the component of vector E at point P parallel to the given line. So first let's solve the first question, which is very simple. E cross F. E cross F. Okay. So how will I solve it? Both are denoted in same coordinate system, which is cylindrical. So rho, phi and z. E cross F they are asking. So first I will write -5, 10 and 3. Then 1, 2, -6. So what will come? A rho -60 -6 plus a phi. So 3 minus 30. 3 minus 30 plus az -10 minus 10. Okay. So what you are going to get? -66 a rho -27 a phi -20 az cap. Right. This is what we are getting. And what is the magnitude of it? The magnitude is coming out to be, for getting magnitude, what you are going to do? For getting the magnitude, what you are going to do? -66 whole square plus -27 whole square -20 square and then under root. So what I am getting? 74.06. Okay. So this is your E cross F magnitude. Let's solve the next question. So first let's solve the question by formula only. By formula I am solving. So what I need to find? The vector component of vector field E at this given point parallel to the line x equals to 2 and y equals to z. Sorry, x equals to 2 and z equals to 3. X equals to 2 and z equals to 3. So that line will be parallel to y axis. I hope you know it because we have already drawn the geometry. Right? You should be able to remember these things. In the x direction, you need to work for 2 and in y direction, you need to work for 3. So what will be the line? The line will be parallel to your y axis. Line will be parallel to y axis. Okay. This is the line. So what will be the unit vector in this direction? Ay cap. What you need to find? You need to find the vector component of E at the given point in ay direction. Find the vector component of, what they are saying, vector component of E at this point in ay direction. So E dot ay cap. Do you remember this thing? Vector component of vector A on vector B or in the direction of vector B, parallel to vector B, or you can say in the direction of vector B. So A dot B cap, then B cap direction also you need to tell because they are asking for vector component. So what they are asking? vector component of vector E vector dot ay, and for the direction I need to put ay cap. So what is my vector E? Vector E is -5 arrow cap plus tan and 3, tan a5 plus 3az. Then dot product you need to do with the ay cap. And what is the direction? Direction is ay. So what you are going to get? -5 arrow dot ay plus tan a5 dot ay plus 3 az dot ay, and then this is the direction. So can you let me know the value of arrow dot ay? X, y, z is outward, okay, arrow, x, y, this is your rho, and what will be your phi? This will be the direction of phi. This we have already seen with the very good concept of geometry. So at least you are not going to write down that particular table here. You should know the angles. This was your angle phi. This would be your 90 minus phi, and what this angle would be? Phi. That's it. You will be able to solve. Arrow dot ay sin phi. So -5 sin phi plus, I will also solve by geometry, do not worry about that, plus tan a5 dot ay cos phi plus, this would be 0, az dot ay. This is your y, z is coming towards you, so that would be 0 only. So that is 0, and direction is ay cap. So from where you will get value of phi? So the point is mentioned, no? Point P is 5, pi by 2, 3. 5, pi by 2, 3. So -5 sin pi by 2 plus 10 cos pi by 2 plus 0 ay cap. So what answer you are getting? -5 ay cap. So this is the answer, okay. This is the answer of second question. How would I solve it by geometry? So let's see it by geometry. It is very easy by geometry. In the examination I am not gonna even draw the geometry because I can see the points. Points are perfectly placed. Let me show you how I am saying these are perfectly placed. So this is your z, this is your y, this is your x. Do you agree to this point? X, y and z. What do you think, where is the point P? 5, pi by 2, 3. In the rho direction you need to work 5, and the angle is made from x axis, that is pi by 2. From x axis you are having pi by 2 angle, that means you are on yz plane. Are you getting this point or not? I think you should be able to understand this point because we have already studied. From here I am making pi by 2 angle. Pi by 2 angle. If I make pi by 2 angle, where I will reach? On this plane. So on this plane, making an angle of pi by 2, you need to work in rho direction, you need to work for 5 meter, and in z direction you need to work for 3. So here you need to work for 5, and in z you need to work for 3. So here will be your point, which is point P. Point P is 5, pi by 2, 3. What will be the direction of rho? Point P is 5, pi by 2, 3. What will be the direction of rho? What do you think? Look, how do we calculate the direction of rho? We take the projection P here, we take the projection of point P to the xy plane, and then we join it to the origin and see in which direction this distance is going. So I take the projection of P on xy plane, but this will come on y axis only, no? Because our plane point P is on zy plane. So if I take the projection, that will come on y axis only, and then I will see what is the distance from the origin, that is 5, and in which direction it is going. In this direction it is going. So this is my arrow cap. This is my aero cap. So from here I got to know that my aero cap is equals to AY cap. What do you think, where will be my A phi cap? Where will be my A phi cap? Going into the plane. Say yes or no. Because you are getting pi by 2 angle and then you need to go into this direction for A phi cap. So A phi cap is going into the plane, right? A phi cap is going into the plane. So from here I get to know that my A phi cap is nothing but minus AX cap. And what is my AZ cap? AZ cap is AZ cap only. Or from AZ cap and A phi cap as well, sorry, from AZ cap and aero cap as well, you can find the value of A phi. How will you find? Rho, phi and Z. So Z into rho will give you phi. Z into rho will give you phi inside. So that is your A phi cap. So what is your A phi cap? Minus AX cap. And what is your AZ cap? That is AZ cap only. So if I just plot the point P, if my point P was something like this, let's just say if it was something like this, then I would not be solving it with geometry. Why? Because I wouldn't know where will be my arrow. Can I intuitively tell which direction it is showing? No. Then I will be solving the problem by the formula. But if my point is something like this, 5 pi by 2, 3, very simple point it is. I know the angle as well. So this is going into the plane. So my aero cap I can directly see that is minus AX cap. My A phi cap is minus AX cap, aero cap is AY cap and AZ is AZ only. So from here if I solve the problem, that is very easy, right? What I need to find? I need to find vector E at point P parallel to this line. Then it would be easy for me to solve. I need to find E dot AY cap in AY cap direction. So what will be my E dot AY cap? So what is my E? Minus 5 arrow. Minus 5 arrow. Instead of arrow, I will write AY. Minus 5 arrow. Plus tan A phi. Plus tan A phi. Instead of A phi, I am going to write minus AX. Instead of A phi, I am going to write minus AX. Plus, then what about Z component? Z was 3 AZ cap plus 3 AZ cap and dot product with AY cap, and that will be in the direction of AY. So AY dot AY will give me 1. So minus 5. AX dot AY will give me 0 and AZ dot AY will give me 0. So minus 5 and then this direction, that is AY cap. So this is the answer. Minus 5 AY cap. So by geometry very easily I am able to solve. In the examination I will just without even drawing this diagram I will get to know where is my arrow, where is my A phi and where is my AZ. Say yes or no. And then directly I can solve. So these kind of questions can come in your examination. Okay, and if they ask the question in the examination, they will give very easy point. And if you keep on applying the formula, there is high chance that you might mess it up or you will take a lot of time. But if you have the good concept of geometry, then you will be able to solve it very quickly. That's why I gave you the concept of geometry. Otherwise, I could have only told the formula. Right? Let's see the third question. The angle E makes with the surface Z equals to 3 at point P. Z equals to 3 surface. What will be the perpendicular component? So, do I need to make the geometry? Here I need to make the geometry, but in the examination you do not need to make the geometry because you will realize what will be the perpendicular component, right? So this is your Z equals to 3. This is Z equals to 3. So this is your perpendicular component, which is this one, AZ cap. Okay, and what do you need to find? Angle E makes with this surface at point P. So AZ cap, and then this is your vector E. This is your vector E. So this angle I will find. Let's just say this angle is coming out to be theta. Then my answer will be alpha. Right? So what will be my theta? My theta will be, my cos theta will be E cap dot AZ cap. Say yes or no. E cap dot AZ cap. So let's find E cap. E cap is minus 5 aero cap minus 5 tan 3. Till now I should be able to remember it. Minus 5 tan plus 3 AZ cap dot AZ cap. Is that correct? No, this unit vector I need to write, no? E cap I have written, unit vector I need to write. So what I'm gonna write here? 25 plus 100 plus 9. So if I solve it, what I'm gonna get? Aero dot AZ 0, A5 dot AZ 0, AZ dot AZ 3 divided by 139. Sorry, 134. 3 divided by 134. So what is the value of theta I am getting? So value of theta you are getting is 74.98 degree. So what will be your alpha? Alpha will be 15.02 degree. So that's the answer. That is the answer. Okay. You try to solve the next problem. I will pause the video once because there is some lag in the video. So you try to solve the problem and then I will show you the solution. Yeah, so let's solve this question now. So h vector is given at point 1 comma pi by 3 comma 0. You need to find these values. So h vector is defined at this particular point. So let's find the value of h vector at that given particular point, because at this given particular point we need to find these values. So first I am writing down the value of h vector. So 1 comma pi by 3 comma 0. 1 comma pi by 3 comma 0. That means rho value is 1, phi value is pi by 3 and z value is 0, right? So h vector, what will be my h vector? So z is 0, this value will be 0, so this whole term will go to 0. What about the second one? E to the power minus 2 sine, what is the value of phi? That is pi by 3, so pi by 6 it would be pi by 6 a phi cap plus what is the value of rho? Az cap. What is pi, sine pi by 6? That is 30 degree, 1 by 2 e to the power minus 2 by 4 a phi cap plus e to the power z, e to the power minus 2, 2 plus minus e to the power minus 2 divided by 4. Am I doing the calculation correctly? This is sine 30, 0, 1 by 2. Okay, pi by 3, here it would be pi by 6. Yeah, no doubt about it. So it would be 30 degree only, that is 1 by 2 e to the power minus 2 by 4, that is coming out to be 0.0338 a phi cap plus az cap. Okay, what I need to find in the first question? H dot ax. So this value dot ax, cap. So what that would be? 0.338 a phi cap plus az cap dot ax cap. 0.0338. What is your a phi dot ax? Do you remember it? A phi dot ax. This was your phi, this was your x. I hope you should remember it. Ax, a phi. And what was the angle between them? 90 plus theta. 90 plus phi actually. 90 plus phi. So what would be the answer? Cos 90 plus phi. So if I do cos 90 plus phi, so answer would be minus sin phi. So this would come out to be minus sin phi, where phi is pi by 6. Sorry, pi by 3. Sin phi is pi by 3. Sorry. And what will be the value of az dot ax? Az dot ax 0. So sin pi by 6, sin pi by 3, sin pi by 3 into something wrong I am doing. Let me check if there is any calculation. Yeah, so I just wrote down this value wrong. No, there is no by 2. Here there is no by 2. E to the power Here e to the power minus 2 only there, no? E to the power minus 2 sin pi by 6. So this error I did here. So this value will come double of this. So let's not calculate this value here. Or let's calculate this value. So all this went wrong here. So what I'm gonna get? E to the power minus 2 divided by 2. So 0.067. 0.067 a phi cap plus az cap. So what I'm gonna get? 0.067 a phi cap plus az cap. So here you are gonna get 0.067 into 0.8666 because that is the value of root 3 by 2. So what you are gonna get? 0.0586 and minus sign is also there, minus sign. So this is the answer, h dot ax cap. Very easy. In the second question, what they are asking? H cross a theta. H cross a theta. Did I tell you any formula of arrow cross a theta? Arrow cross a theta or a phi cross a theta? No. Right? Or az cross a theta? No. Between different coordinate system, I never told you any formula of cross product. We were only seeing dot product. All these we saw dot product. So how will I solve the problems based on cross product? So I will consider this as another unit vector, a theta cap. So can I convert a theta cap in terms of arrow, a phi and az? If I am able to convert a theta cap in terms of arrow, a phi, az, then my problem will be very easy. Right? I just need to convert a theta cap into arrow, a phi and az. Right? So what I need to calculate? H cross a theta. In the second problem, I need to calculate H cross a theta. Okay. So what I am doing? H cross, I am considering this as a vector B, where vector B is a theta cap. So now I am gonna represent my a theta cap in terms of arrow, a phi and az. So for that I can either use my matrix or I can solve into by the intuition using the geometry. So let's solve it first by using the matrices. Okay. So I will solve using the matrices now. So rho equals to r sin theta, I know, phi equals to phi, z equals to r cos theta. So this table I can write very easily. R theta phi, I am going opposite, so I need to write horizontally. Sin theta 0, cos theta, then just the differentiation, right? So this is what I am gonna see. Here I would need the value of theta. So what will be the value of theta? How would you get to know the value of theta? What is theta? Theta is tan inverse rho by z. Do you remember by the diagram? Theta, tan inverse rho by z, right? So tan inverse, value of rho is 1, z is 0. So tan inverse infinity, what that would be? 90 degree. Tan inverse infinity will be 90 degree. So here in place of theta I can replace 90 degree. $90 degree, 90 degree, 90 degree. So what will be your a theta cap? Because I am only interested in a theta cap. I am not interested in AR or a phi. So what will be a theta cap? Cos 90 will be 0, this will be 0, this will be minus 1. So 0 into arrow cap, 0 into a phi cap, minus 1 into az cap. So what I am getting? This is what I am getting. How I would have solved it using geometry? So this is my x, sorry, this is my z, y and x. Let's see where are my points in Cartesian coordinate system. This is your Cartesian coordinate system. Do you agree? Sorry, not Cartesian, sorry. This is your cylindrical coordinate system. Do you agree to this point? 1 pi by 3 direction, in z you are going 0. Rho phi z is mentioned. You are going 1 radially, making an angle of pi by 3, and in z direction you are going 0. So where will be your point? My point will be on xy plane. Do you agree to this point? Because in z direction I am going 0, that means certainly I will be on xy plane. So this is where my point will be, which is having a distance of 1, an angle of pi by 3, and in the direction of z the distance is 0. Okay. So this is my arrow. Forget about all these things. What I need to find? I need to find the direction of a theta cap. I need to find the direction of a theta cap. So this is the point P. This is the point P. What will be your theta? Theta is the angle made from z axis. So this will be the theta. What do you think, what is this theta value? Pi by 2. In the geometry only you can get to know the value of theta is pi by 2. How did you get to know? For the given position vector, this is your position vector. This is your position vector. The position vector makes how much angle from z axis from up to down direction. From up to down direction, how much angle position vector will make? That is pi by 2. And what will be the direction of theta? The angle is coming like this. This is your z axis. This is your z axis. From z axis you are having the angle on zy plane, xy plane. So you will have the direction going downward, directly going downward. Say yes or no? This is your angle and direction will be directly going downward. So this will be the direction of a theta cap. And what you are getting a theta cap, that is, if you are going directly downward, this was your z cap, this was your z cap, and you are going directly downward, so your a theta cap is minus a z cap. So directly by these things I would be able to solve my problem. In the examination, if these kind of questions are coming, I am 99.95% sure that that question will be solved by geometry very easily. You do not have to apply these equations. If you feel good with equation, then you can apply the equation as well. If you are feeling good with geometry, try to solve the question by the geometry in the examination, because you will be able to solve very quickly. Here you go to know what is my position vector, what is my theta. A theta is going downward, so minus a z cap, very easy. Okay, so I do not even need to make these metrics and all. There I will not be thinking rho equals to r sin theta, phi equals to phi, z equals to r sin theta, then I write down in this manner. That also you can do, but here it is very easily found. So a theta I have, h vector I have. So h cross a theta I need to do, which I first implemented as h cross b, where my h is what? Rho component is 0, h is my 0.067 aero cap, 0.067 aero cap plus az cap, not aero cap, it was a phi cap, right? Or aero cap it was a phi cap, plus az cap. And what is my vector b? Vector b is coming out to be minus az cap. So can I do h cross b? Certainly you can do h cross b. How will you do h cross b? Simply you will write down this thing, rho phi and z, rho phi and z. What is the component of rho? 0.067. No, component of rho is 0. Sorry. Component rho of 0. Here it is 0.067. Z component is 1. Here it is 0, 0 and minus 1. Right? So if I find with respect to arrow, what I am gonna get? With respect to arrow, minus 0.067, right? And minus 0, that would be 0 only. Minus a phi. With respect to a phi, you are gonna get plus a phi, you can say. So 1 into 0 minus 1 into 0, 0 only. With respect to az also, you are gonna get, with respect to az, 0 into 0 is 0 only. So what is the answer you are getting? Minus 0.067 aero cap. This is the answer of h cross b. Were they asking the magnitude? No. H cross a theta they were asking. Simply in place of b I can replace a theta. So this is the answer they were expecting, and this is the answer we have given. I will check the answer. Yeah, correct. Okay. So this is how we need to do. The vector component of h normal to the surface rho equals to 1. Vector component of h normal to the surface rho equals to 1. What will be the normal to the surface? Rho equals to 1. What will be the normal of that particular surface? C. Rho equals to 1. Normal component. Aero cap, right? You have seen the previous lectures. Rho equals to 1, normal component will be aero cap. So what you need to find? Vector component of h vector in the direction of aero cap. So what that would be? H dot aero cap into aero. What is the value of h dot aero cap? Vector component I need to find, that's why I am showing the direction. What is the value of h dot aero cap? In the h there is no component of aero. Basically it is 0 into aero cap plus 0.067 into a phi cap plus az cap dot aero cap, and then all will have the direction aero cap. But what did you get to know here? Aero into aero, it would be 0 only. Aero into phi, 0. Az into aero, 0. So always it is 0. So 0 into arrow cap, or you can directly write 0. So h into arrow cap is coming out to be 0. So answer is 0. And what is the last question? Scalar component of h tangential to the plane z equals to 0. Tangential to the plane z equals to 0. What will be the tangential component? Z equals to 0. Z equals to 0. So for z equals to 0, tangential component will be what? Arrow and a phi. Arrow and a phi. And what will be the normal component? Normal component will be az cap. Because what will be my z equals to 0 plane? If this is your z, this is your y, and this is your x. X, y, z. So z equals to 0 plane is xy plane only. Say yes or no? All the values of xy, but z value is 0. So what will be the normal component? Normal component will be z, and what will be the tangential component? That will be xy. So tangential component will be xy, or you can say if this is my rho, arrow, az, a phi, because az will be in this direction and rho and phi will be tangential only. So rho and phi component. So basically what will be my answer? Rho component is not even there, phi component I need to write. What they are asking? Scalar component also you need to tell. So scalar component of h in that tangential direction. The scalar component of h in the tangential direction, or you can say parallel direction. Tangential also you can write. So that would be 0.067 a phi cap. But they are asking the magnitude, because they are asking the scalar component. So scalar component would be 0.067. So that's the answer. Are you getting this point? There are two components. One is perpendicular, one is tangential. So perpendicular component I do not need to write. I need to write the tangential one. So this is the tangential one, and they are asking the scalar component. That means they are asking the magnitude 0.067. Well and good. Let's move to the next question. So vector field is given at point P. This is the point P is given. You need to find a unit vector which is perpendicular to D and it is tangential to the cone theta equals to 150 degree. Try solving it on your own. You have the concept. Use your brain. If you are able to solve it, then believe me, you have achieved something good. Like these lectures are very helpful for you. And even if you are not able to solve, then there is no need to worry, because this is not a very straightforward problem. But think about it. Think as much as you can. Pause the video and think as much as you can. Theta equals to 150 degree. Although 150 degree will be somewhere here, somewhere downward, but I am assuming 150 degree to this angle only. Theta equals to 150 degree. I just need to show you the trajectory, or I just need to show you the surface. What will be the surface you will be getting? Cone. Do you remember it? Theta equals to 150 degree. We have drawn it. If you go, you see the second last or third last structure, you would realize we have already drawn it. Theta equals to 150. So this kind of cone you will be getting. This is the structure they are asking. So unit vector P should be perpendicular to D. Sorry, unit vector at point P should be perpendicular to D. Perpendicular to D and tangential to theta equals to 150 degree. What will be the tangential component of theta equals to 150 degree? What will be the normal component? Can you let me know? What will be the normal component? Normal component will be a theta cap. So if your vector is tangential to these vectors, because what they are saying, it should be tangential to the cone theta equals to 150 degree. So that means this should be somewhere here. The vector should be somewhere here. It should be tangential to theta equals to 150 degree. That means it has to be normal to a theta cap. Tangential to theta equals to 150 degree shows that it is normal to a theta cap. Are you getting this point or not? Did you understand this point? This is a cone. Perpendicular component is a theta cap. Okay. Now you are saying that my vector is tangential to the cone. That means it has to be perpendicular to a theta cap. So what I am getting? Your vector is, my vector is that vector that I need to find. A unit vector I need to find that is perpendicular to what? It is saying, they are saying that it is perpendicular to D as well, perpendicular to D and a theta. Say yes or no. So what do I need to find? My unit vector will be D cross a theta and then their magnitude. Why is that so? Because before starting the lecture I told you one thing, you need to find a unit vector which is perpendicular to two vectors A and B, that would be A cross B divided by their magnitude, right? Because n cap will be somewhat this. So A cross B and then there is their magnitude, right? Say yes or no. So what I am going to find? First I am going to find D cross A theta. This is my task now. D cross A theta. So what is my D? D at this point, at point P they are asking. So D at this point P, that would be tan sine 50, sine 150, tan sine 150 degree AR cap, tan sine 150 minus 1 by tan sine 150 cos 330, minus 1 by tan sine 150 cos 330 plus r square a phi, that means 100 a phi cap, 100 a phi cap. Let me see what the answer we are gonna get. Minus 5 AR cap minus 0.043 A theta cap plus 100 A phi cap. So this is the answer of D vector you are getting. And what is your A theta? A theta cap, that is A theta cap only. So what I need to calculate? D cross A theta first. D cross A theta. So what I'm gonna write? R theta and phi. What is the value of? Okay, here is the value. Minus 5 minus 0.043 and then 100. And A theta 0, 1 and 0. So AR component will come 0. Sorry, AR component will come minus 100. Sorry, minus 100 AR cap plus A theta cap component will come 0, A phi component will come minus 5. So this matrix you would be able to solve, right? This is your D cross A theta cap, right? So what will be my vector that is perpendicular? So that will simply be minus tan AR cap minus 5 A phi cap divided by their magnitude. So that will be 1000 square plus 5 square. So let me see the answer now. So that would be 0.99 AR cap minus 0.049 A theta cap. Sorry, A phi cap. AR cap and A phi cap. So this is the answer. Okay, very easy question. Just you need to have the basics clear, nothing else. Okay, if it is perpendicular, that means they are the tangential component. Tangential component, this is the tangential component, and perpendicular one more component is given. So your vector should be perpendicular to both. So for that we have the formula, or we have the concept as well, that if a particular vector is perpendicular to both of the vectors, then I just simply need to take the cross product. Then I need to divide the magnitude. So I took the cross product and divided the magnitude. That's it. Okay. So very good question it was. It would test you on your basic. Yeah, so let's solve this question. You need to determine the dot product of the position vector of the following 2 points. So 2 points are mentioned, but they have mentioned the point, they did not mention the position vector. So if I give you a point in cylindrical coordinate system, this is in cylindrical coordinate system only. So can you tell me the position vector of this point? No, because I did not even teach you. Can you tell me the position vector of this point? I did not even teach you. How would you able to tell it? Neither you can tell the position vector of this point, right? But what you can do, you can convert it into Cartesian and then you can tell the position vector of the point. Because if I know, if I convert it into Cartesian, let's just say if I convert it into the same point P is there, I convert it into x1, y1 and z1, then what will be my position vector? x1 ax cap plus y1 ay cap plus z1 az cap. And if I can do the same for this one, x2, y2 and z2, then what will be my position vector? x2 ax cap plus y2 ay cap plus z2 az cap. So let's find out the values. So x1 I need to find. So what will be x1? x1 will be 5 cos 53.13 degree. So that would be 3 by 5. So this would be 3. What will be your y1? y1 will be 5 sine 53.13 degree. So that would come out to be 4. And what is your z1? z1 is 1 only. So what is your position vector OA? That is 3ax cap plus 4ay cap plus az cap, right? What about x2? x2, 2 cos 90, that would be 0. What about y2? y2 is 2 sin 90, sin 90 is 1, that would be 2. And what is your z2? z2 is minus 5 only. So what will be your OB vector? OB vector will be 0 ax cap plus 2 ay cap minus 5 az cap. If I need to find, what I need to find? Dot product. So can I do the dot product? 3 into 0 plus 4 into 2 plus 1 into minus 5. So 8 minus 5, answer is 3. So that's the answer. Okay. So do not apply anything, like at some places you might have studied that the position vector in Cartesian in a cylindrical coordinate system I can write in this manner. I did not teach it, but at some place you must have studied this thing. There is no meaning of this. If you write the position vector in this manner and then you solve the problem, your answer will be wrong. Because how will I write down that position vector? 5 AR cap plus 1 AZ cap. This is wrong. This is what I am saying. 5 AR cap plus 1 AZ cap, and here I am going to write 2 AR cap minus 5 AZ cap. What is the answer you will get if you do the dot product? 10 minus 5, which is wrong. Answer is 3. So do not do this thing that position vector in a Cartesian coordinate system is given by this. No. How will be the position vector written? If you want to write down the position vector in cylindrical coordinate system, what you will do? You have got this answer. Now you can convert it into Cartesian. Now you can convert it into cylindrical. This is already in Cartesian. Now you can convert it into cylindrical by the matrix. But directly do not write that 5 AR cap plus 1 Z1 cap. So that 1 Z cap. So that I did not teach. But if you have studied it, at some other place, then just forget it. That will not work. So first convert it into this, then find out the value of AR, Aero, A phi and AZ. Similarly, you can do for AR, A theta and A phi as well. Okay. So yeah, that's the thing. So at some places I found this, so that's why I took this problem. Okay. So that's the answer, that is 3. Now we will move to differential length, area and volume based problems. So 2 problems we are going to solve. This one and one more problem is there. So let's pause the video once. Let's drink some water and then we can start solving these 2 problems. So you can try solving this problem. First solve by geometry. What do I mean by geometry? BC length. Do you know what is BC length? This length is BC length. Basically, this is your BC length. This is your BC length. Solve by geometry. All the problems you can solve by geometry. Forget about this is the problem of EMFT. Okay, forget about that. This is just a problem of simple geometry. How will you able to solve it? If you are asked this question, that surface area and all these things, so how will you solve? By using geometry. So that you need to do. Okay, so try solving it. I will drink some water and then I will come back. Yeah, so let's start solving this problem. You need to find the distance BC. So what is the distance BC? By geometry directly I can say that it is 10 meter, right? 10 unit I will write, or 10 meter I can write. So let's solve the first one. By geometry I can tell it is 10 unit. Or if I want to solve using coordinate system, then how would I solve it? If I take a small length here, what I would take? dz. Why dz? Because here z coordinate is changing, right? Only z coordinate is changing. X, y are same, only z coordinate is changing. So what will be my total change? Only z coordinate is changing. From where to where? From 0 to 10. So if you do the integration of dz, what you will get? Z only. From 0 to 10. So 10 minus 0, what is your answer? 10 unit. Second, I need to find distance CD. CD I need to find. So this is a cylinder, right? This is 1/4 part of the cylinder. Are you understanding this point? X, Y, Z, 1/4 part of the cylinder. Only 1/4 part. Here from here, Z is there, X is there, Y is there. So 1/4 part of the cylinder it is. So what will be your DC length or CD length? That will be 2 pi r by 4. 2 pi r by 4. The whole circumference is 2 pi r. This complete is 2 pi r. And this is 1/4 area. Or you can say 1/4 circumference. So that would be pi r by 2. So what would be the answer? R value is 5. What is the radius? Radius is 5 only, no? This is 0, here point is 5. So radius is 5. So radius is 5. So answer will be 5 pi by 2. Or if I need to solve it using coordinate system, then how would I solve it? If you are moving across CD, then what is changing? If you are moving across CD, then your value of phi is changing. Are you getting this point? Value of R is constant. If you are moving across CD, then value of R is constant, that is 5. Here also R is 5, R is 5, R is 5. Value of Z is also constant. Value of Z is 10 only, because the height is constant. What is changing? Phi is changing. And if phi changes, then what length you cover? If phi changes, then what is the length you cover? Rho d phi, right? Do you remember this point? D rho, a rho cap, rho d phi, a phi cap, and dz, az cap. So if phi changes, then you cover rho d length. So I am covering rho d length. Rho d phi length. Here rho is constant, but phi is changing. How phi is changing? Tell me how phi is changing. Tell me what is the value of phi at C. What is the value of phi at C? 90 degree. Say yes or no? Because point C is in YZ plane. Point C is in YZ plane. So from x axis, how much angle you are making? What do? You take the projection to down. Then from x axis, how much angle you are making? 90 degree. And what is the value of phi here? You take this down. You take the projection of this point. From x axis, how much angle you are making? 0 degree. You take the projection down. From x axis, how much angle you are making? 0 degree. So phi is 0 degree here. So if you are going in CD, from C to D you are going, so your angle is changing from 90 degree to phi. 90 degree to 0. Your angle is changing from 90 degree to 0. And on the complete length, phi is constant, that is 5. Sorry, rho is constant, not phi. Rho is constant. In the complete length, rho is constant, that is 5. So 5 will get out d phi from pi by 2 to 0. If you solve it, what you are going to get? 0 minus pi by 2. So what is the answer? Minus 5 pi 2. Minus 5 pi by 2. But length cannot be negative, so we have to take the magnitude. So CD would be 5 pi by 2. So by geometry everyone can solve, but this is important. This concept will be used when we study line integration. So you need to tell how much small length I am taking. Okay, let's find out the third thing. What is the third thing? Area of ABCD, surface area ABCD. Area ABCD. So for a complete cylinder, for a complete cylinder, what is the surface area? Do you know? 2 pi RH. 2 pi r, 2 pi r, 2 pi r, h times. It is 2 pi RH, right? Now I am solving by geometry only. So the complete area is 2 pi RH. Complete surface area 2 pi r, 2 pi r, 2 pi r for h distance. But this is one fourth part. So divided by 4. So pi RH by 2 would be your answer. What is the value of pi? Pi is 5 only. What is the value of r? R is 5 here. R is 5 here. What is the height here? Height is 10 divided by 2. So what you are going to get? 25 pi unit square. Are you able to understand this? Very easy. By the geometry we are solving it. Now how would we solve? So ABCD surface. Which one is ABCD surface? This is ABCD surface. What is constant here on ABCD surface? On ABCD surface, what is constant? Can you let me know? R is constant. On surface, R is constant. Are you getting this point? So this surface is R equals to constant. The equation of this surface is R equals to constant, because here R is constant. If you take this point, this point, this point, this point, at every point value of R is constant. So equation of surface ABCD. Equation of surface ABCD, that is R equals to constant. So unit perpendicular vector, what will be your unit perpendicular vector? Unit vector or unit perpendicular vector, that would be AR cap. So if you know that DL length, D rho, rho d phi, R equals to constant, or I can say rho equals to constant. Okay, because we are writing in terms of cylindrical coordinate system, so I can say rho equals to constant. Radius is constant here. Basically, radius is constant. So R equals to constant, or better I should have written rho equals to constant. The equation of ABCD plane is rho equals to constant. Rho equals to constant. So if you remember this thing, d rho a rho cap, rho d phi a phi cap, plus dz az cap. So if this is your unit vector, then what will be your surface area? My surface area will be defined as rho d phi dz. Now I need to take the direction. Which direction I will take? Going outward. If I need to take the direction, I always told, if your surface is a part of volume, if your surface is a part of volume, then always the direction will be taken outward from the volume. So I will take arrow direction. Here unit vector is plus minus arrow cap, but here I will take arrow direction. And if I am taking direction, then I will take the vector sign as well. But what do I need? I need only magnitude. So what will be my complete surface area? That would be rho d phi dz. That would be the complete surface area. But here two limits will come. The limit of phi will also come, limit of z will also come. Are you getting this point? On this surface area, what all things are changing? Phi is also changing. Phi is changing from 0 degree to 90 degree. Phi is changing from 0 to 90 degree. And how z is changing? Z is changing from 0 to 10. Z is changing from 0 to 10. So your surface area of ABCD. So rho is constant. What is your rho? On surface ABCD, what is your rho? 5. Rho is 5. Rho is constant. Your phi is changing 0 to pi by 2. And your z is changing from 0 to 10. Are you able to understand this? What you are going to get? 25 pi unit square. So this practice you should have. First you need to know what is the equation of the plane. If you know the equation of the plane, then you can get to know what is the perpendicular vector, perpendicular unit vector. If I know the perpendicular unit vector, that is coming out to be arrow. So drop arrow and take the rest. Rho d phi dz. So rho d phi dz, that would be my surface area if I only talk about the magnitude. And then phi is changing from 0 to 90 degree and z is changing from 0 to 10. Okay, let's see the next one. C D. What D is saying? ABO. ABO, downward, ABO, this one. What do you think, what is constant here? Value of Z is constant, right? Because here on this surface value of rho is also changing. Here rho is different, here rho is different, here rho is different. You can check at any point, here rho is different, here rho is different. So value of rho is changing. Phi value is also changing, 0 degree to 90 degree. 0 to 90 it is changing, right? Here it is 0 degree, here it is 90 degree. But value of Z is equals to 0 only. Value of Z is constant, right? So by geometry you can solve on your own. Now I am going to solve directly, or okay, by geometry also we solve. So surface area of what we need to find? Surface area of ABO. ABO. So what that would be? Pi r square by 4. Because a complete circle will have pi r square area divided by 4. So pi by 4. Here I should have written rho actually. In place of r I will write only rho, because radius is represented by rho here. Here also I will write down rho, because radius is represented by rho. Okay, so pi by 4, what is the value of r? That is 5 square. So 25 pi by 4 meter unit square, right? I hope you must have understood this was a complete circle. Pi r square, pi rho square divided by 4. Now let's here I got to know that what is changing? Z is change. Sorry, Z is constant. So equation of ABO. Equation of surface ABO, that is Z equals to constant. Unit perpendicular vector is plus minus AZ cap. So what will be my ds? Only the magnitude I am writing. What that would be? Forget about dz, these two will come. Rho d rho d phi. Rho d rho d phi. What is the interesting thing here? Both rho and phi both are changing. So rho is changing from 0 to 5 and phi is changing from 0 degree to 90 degree. So if you differentiate with respect to rho, what you are going to get? Rho square by 2. Sorry, not differentiation, sorry, integration. If you integrate with respect to rho square by 2 from 0 to 5. And what about phi? What about d phi? If you differentiate with respect to phi, what you are going to get? Phi only. Rho d rho, what that give you? Rho square by 2. And d phi, what that give you? 5. Right? That would give you 5. So from 0 to pi by 2. So pi by 2 into 25 by 2. So here only I will write 25 pi by 4. Okay, surface area. Now E. What E is saying? AOFD. AOFD. This surface area I need to find. AOFD. You let me know what is constant here and what is changing. R is changing and Z is also changing, but phi is constant at 0 degree. Okay, AOFD. These things we have already seen in the basics, so now you will not be afraid of all these things, right? Area AOFD. If I need to solve by geometry, then what it would be? Geometry. This is simply a rectangle. So 10 into 5, 50. This is simply a rectangle. No, this height is 10 into 5, 50. So by geometry it will be 10 into 5, 50. But what is the equation? Equation is, here what is constant? Here phi is constant. So if phi is constant, then I will only drop a phi cap. If I drop a phi cap, then what will come? D rho and dz. So what will be my ds? D rho and dz, right? So what will be my s? So rho will go from 0 to 5 and z will go from 0 to 10. D rho and dz. So what is the answer? 50. That's the answer. Okay, very easy problem, very easy kind of problems these are. One more part is left, that is F. What do we need to find? Volume. Volume we need to find. So by geometry, if I solve volume, by geometry, what is the complete volume of your cylinder? Pi r square h, but it is the fourth part of that. Pi r square h by 4, pi rho square h, pi rho square h by 4. So pi into 25 into 10 by 4. So 250 pi by 4. Okay, so that would be the answer. But if I need to calculate the volume, what is the volume? Rho, basically all these will be multiplied. Rho d rho d phi dz. Rho d rho d phi dz. All these will be multiplied and limit of all will come. So here rho is going from 0 to 5. Phi is going from 0 to pi by 2 and z is going from 0 to what? 10. So what is the integration of rho? Rho square by 2 from 0 to 5. What is the integration of phi? What is the integration of d phi? D phi, integration of d phi is 5 only, 5 only. So you are going from 0 to pi by 2. And what is the integration of z? dz, that is z only. You are going from 0 to 10. So 25 by 2 into pi by 2 into 10. So what you are getting? Here it should be unit cube. So here also you are getting the same thing, 250 pi by 4 unit cube. That's it. This is the answer. Okay. So understood? Very easy question. Just you need to understand how to take the small length. Okay. So let's solve this question. So disregard the differential length and imagine the object is a part of spherical shell. So let us say this is my spherical shell. So this particular object is a part of this spherical shell, which is this one only. Now you will say that, sir, this is not a spherical shell. Yeah, this is only some part of the spherical shell. The same part will be downward, same part will be this side as well, same part will be this side as well, and same part will be behind that as well. So this is 1/8 part of the spherical shell, right? And a very small part of that is this particular structure. So this is what they are saying. A very small part of a spherical shell is this particular structure. This is what they are saying. Okay. So I will just mark it. This is this. Now what they are saying? R equals to 3 for the surface AEHD. 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 So for all R is equals to 3. So certainly if this is increasing, this would have been R equals to 5. Can you let me know? Can you let me know in this diagram where is AEHD? In this diagram, where will be AEHD? AEHD. All are 3. Then all these points will be at 5 radius. Are you getting this point? AEHD. All these points are at 3, and then these points will be at 5. Understood? If you are not able to understand this, then also it is fine. In the diagram, it is completely clear. This is R equals to 3, then certainly this has to be R equals to 5. The scene is, this is your coordinate, this is your coordinate, and here this is the structure. This structure is here. Whatever it is, where it is, I am not making it fairly. So this structure is with respect to this regard. So here R equals to 3. What will be here? R equals to 5. So distance will increase, no? This point will be far away from the origin. This will be far away from the origin. This is your B, this is your A. So this is near to origin, this is far from the origin. So here it is R equals to 3, here it is R equals to 5. What do you think? What about theta? This will have less theta value or this will have less theta value? Theta is the angle measured from z axis, right? Theta is the angle measured from z axis. So one point is here, that is A, another point is downward, that is B. So this will be theta 60 to 90. So this will be 60 and the other one will be 90 degree, right? This would have been mentioned as well, that theta is 60 degree for AEFB. AEFB. For all these points, theta is equals to 60 degree. Theta is equals to 60 degree. Then certainly for them it has to be 90 degree, right? What about phi? Think about it. What about phi? Although they have mentioned it that for ABCD, phi ABCD, phi is 45 degree. Then for the other one it would be 60 degree. But think about it. What is your phi? Take the projection of the point on xy plane, take the projection of the point on xy plane and then measure the angle from x-axis. This is your phi. Can you visualize that all these points will be same on the xy axis? Like this will be A, this will be D. So they will make the same projection. B and C, they will make the same projection. Basically both will be on the same line. So they will make how much angle? 45 degree angle. And the other one will make larger angle. Are you getting this point? A, D, B, C. Although it is mentioned in the question, you do not need to think it. But let's just say if you need to think as well, that which angle will be lower, which angle will be larger. If they give this structure and then they only write down these values, they do not even write this thing, then how will you think? If they give you this structure, here they did not show the complete spherical shell. If they show the complete spherical shell, then you can think on your own that which one will be phi, which one will be lesser phi, which one will be more phi. So here these will be lesser phi, right? And these will be more phi. Because if you take the projection of these points, it will come here. If you take the projection of this point, it will come here. So it will make angle this much, it will make angle this much. So that will be more, right? So same goes here, same goes here. So I will just change the color of pen. So I will write down phi equals to 45 degree. This I do not need to hide. Phi equals to 45 degree. And to the other plane, phi equals to 60 degree. To the other plane, phi is equals to 60 degree. Okay, let's start solving the problems. Let's start with the first one. Distance DH you need to find. DH. Where is DH? DH. This distance you need to find. Let me know what is changing here. Here. This is r sin theta d phi. Let's write down the length first. dr ar cap plus r d theta a theta cap plus r sin theta d phi a phi cap. Here phi is 45 degree, here phi is 60 degree. So here what is changing? Phi is changing. Theta is 90 degree, theta is 90 degree. R is 3, R is 3. So what is changing? Only phi is changing. You can understand this is phi equals to 45 degree. And what is phi here? Phi equals to 60 degree. So let me show in the next diagram. I am only showing the things which are important here. Phi equals to 45 degree and phi equals to 60 degree. So only phi is changing. So this value is changing. So what will be my length? My length dh will be what? Your phi is changing. So r sin theta d phi. And from where to where phi is changing? Phi is changing from 45 degree to 60 degree. Okay. What is the value of r? R is constant here, that is 3. So I can take it outward. What is the value of theta? Theta is also constant, that is 90 degree. Okay. Theta is 90 degree here. Sin theta, just a second. Yeah, okay. Sin theta is 90 degree. And what about phi? I was thinking sin theta is equal to 0. Then that's what that's the error I was doing. So sin 90 is 1 actually. And what is the value of phi? Phi is 15 degree. D phi. If you take the integration of phi, d phi, what you are gonna get? Phi only. And from 45 degree to 60 degree you are going. So what will be that difference? 15 degree. So 3 into 1 into 15 degree. What will be 15 degree? 180 degree is equals to pi. So 1 by 180 into 15. Pi by 12. Right? So 15 degree is pi by 12. Right? So that would be pi by 4 unit. This will be pi by 4 unit length. Let's see the second one, FG. FG. So here what is changing? Theta is changing. FG. So what is the value of theta? Theta is 60 degree here and here it is 90 degree. So value of FG. So R d theta. Theta is changing from 60 degree to 90 degree. What is the value of R here? 5. Value of R is constant 5 on this FG line. FG line value of R is constant, that is equals to 5. And theta is changing from 60 to 90. So the difference is 30 degree. And what do you mean by 30 degree? Pi by 6. So this is the answer. 5 pi by 6 unit. Right? Very easy question. 30 degree is pi by 6. What about the option C? In option C, surface area AEHD. AEHD. This is the surface area. AEHD. So what is constant here on AEHD? What do you think? Theta is 60 to 90, that is changing. R is constant here. Phi is also changing from 45 to 60 degree. Phi is changing here. Theta is changing here. What is constant? Only R is constant. So AEHD. AEHD. Let's not ruin this diagram. Let's make it more clear. Otherwise, when you revise the notes, you will not be able to understand. Now you will be able to understand that equation of this plane AEHD is R equals to constant. R equals to constant. If R is equals to constant, then what will be my ds? Because here the perpendicular vector will be AR. So forget about AR, this will be your ds. So what that would be? R square sin theta d theta d phi. R square sin theta d theta d phi. So what is the change? Change is happening in case of theta. R equals to constant, but what is the value of R here? R is equals to 3 here, right? From 3 to 5 we are going, so R is equals to 3. So in this plane, R is equals to 3. So instead of writing R equals to constant, I will write R equals to 3. And value of theta is changing from 60 degree to 90 degree. And value of phi is changing from 45 degree to 60 degree. Okay. So R is 3, so this is 9. Value of phi. What do I need to do? I need to take two integrations. One is with respect to phi, d phi, that is changing from 45 to 60 degree, 15 degree change. Another one I need to take from sin theta d theta, that is changing from 60 degree to 90 degree. Okay. So what is my answer? 9. 45 to 60 degree, that is 15 degree, and 15 degree is equivalent to pi by 12. 9 into pi by 12. And what about this sin theta? What is the integration of sin theta? Minus cos theta, right? Minus cos theta, and you are going from pi by 6 to pi by 3 to pi by 2. Okay, so cos pi by 2 is 0 only. So 0 minus minus, so this will be a positive value only. So cos 60 is, what is cos 60? Cos 60 is 1 by 2. So 3 pi by 8. So this is the answer. This is the length. Sorry, this is the surface area, 3 pi by 8. Okay, this is the surface area. What else we need to find? Surface area of ABCD. Surface area of ABDC, they are saying ABCD should have been written. ABCD should have been written. Surface area ABCD. So this was C, this is D. ABCD. What is the equation of this particular plane? ABCD. Let's go here. R is changing, and what is changing in this direction? In this direction, what is changing? Here your theta is 90 degree, here it is 60 degree. So theta is also changing. So what is constant? Phi is constant, because phi is constant on this particular plane, that is phi equals to 45 degree. So equation of this plane is phi equals to 45 degree, or I should write pi by 4. So here what will be the unit vector? A phi cap, perpendicular unit vector. So what will be my ds? So forget about a phi term. Forget about a phi term. This will come r dr d theta. R dr d theta. Okay. So if I need to write down s. Okay. So here also I need to put integration. No? If I am putting integration on both of the side. So if I want to write s, then I need to take the limits as well. So r dr. So what is the limit of r? From where to where r is changing on ABCD? R is changing from 3 to 5, and theta is changing from 60 to 90. R is changing from 3 to 5, and theta is changing from 60 to 90 degree. So here I am going to write theta. So r square by 2, 3 to 5, and theta 60 degree to 90 degree. So 25 minus 9, that would be 16 by 2. So 5 square 25 minus 9, that would be 16, 16 by 2, that is 8. So 8 into 30 degree, what will be 30 degree? 30 degree will be pi by 6, right? So it would be 4 pi by 3 unit square. Let's see the last one. E, what they are saying, you need to find the volume of the object. So what will be the volume? All the limits will come, and what will be the volume? In volume you need to take all the values. So r square sin theta d theta d phi dr. So r square sin theta, okay, from here you get to know r square sin theta. Now all the limits will come, dr, dr, d theta and d phi. So value of r square dr I will do, value of I will go from 3 to 5, and then sin theta d theta I will do, this I will do, this I will do, and only d phi I will do. This is the scene, no? R square dr sin theta d theta and d phi. So value of r is going from 3 to 5, value of theta is going from 60 degree to 90 degree, and value of phi is going from 45 degree to 60 degree, right? 45 to 60, value of phi, 45 to 60, 60 to 90, and 3 to 5. Okay, fine. So let's write down the answer. R cube by 3 from 3 to 5, and then minus cos theta 60 degree to 90 degree, and then phi, that is 15 degree, and 15 degree is pi by 12. Okay, so here 125 minus 27 divided by 3, right, because 5 cube is 125 minus 27 divided by 3, and cos 90 is 0, cos 60 1 by 2, and this is pi by 12. So this is 98 8 pi divided by 72. What I can do? So by the table of 2 only it can get cancelled, or is there anything else? Let's check out. 49 pi divided by 36, that will be the answer, unit Q. Okay, so yeah, that's it about your first chapter, that is coordinate system. Now we are going towards vector calculus. So all these things will be highly used in vector calculus. So if you directly start from vector calculus, you are not going to understand anything. Okay, so coordinate geometry you need to study, then only you can understand vector calculus. Okay, so let's move to the next chapter, that is our vector calculus. Thank you very much.